I started to go over this without recording, so you guys will quickly see that I got my AC of negative 45. I went through my factors and got my winning factors of 5 and negative 9. But the key thing is when you split up this middle term of xy, they both have an xy behind it. Okay? So we looked at the first two, we factored out its GCF. We're looking at the back two right now. We factored out its GCF. We still have to come up with what's left. Negative 15 divided by a negative 3 is a positive 5. Is that right? And then we had two y's. We took one out, so we have 1. And like I said, celebrate the small things in life. We want those to match. So that's exactly what we want to happen. So this GCF of 3x plus 5y can be factored out in front. And while we do that, what's left of the first term? X. And then minus 3y is left from the second. And again, if you guys start to question it or you think it looks weird, you can always distribute and see that it ends up being that original trinomial that we had. So we can always check these. All right, so let's look at the next one. Honestly, the only thing that's weird about this, I think, is, no, I don't think there's anything weird about this, when we just have to try a lot of options before we get there, okay? So 4 is our A, 15 is our C, so our AC ends up being 4 times 15 or 60. So over here we got to think of things that multiply to 60, but add to 17. So this is one, again, if you're comfortable with your times table, you might get to them right away, but how the system method always works, okay? First of all, I'm going to be happy to celebrate the small thing. Everything's positive, so I only need to worry about positive factors, all right? So let's start with 1 and 60. What does that add up to? 61. I don't want it. 2 and 30. What's that add up to? 32. I don't want it. 3 and 20 adds up to 23, right? Yeah, he already has the answer. 4 and 15 adds up to 19. I don't want it. 5 and 12 adds up to 17. Okay, that's who I want. So I like this one because it shows you that, and I know I went quick, but I trust you guys could do 60 divided by 1, 60 divided by 2, right? So it just shows you the systematic method will get you there, okay? Just have patience. So I just took 60 divided by 1, 2, 3, 4, 5 until I got to my factors. Besides that, this is just like the front ones, okay? So we're going to leave 4d squared as is, 15 as is, and we're going to split up 17d as 5d plus 12d. So 4d squared plus 5d plus 12d plus 15. If you want to flip-flop the order because you really want the 4 with the 12 and the 5 with the 15, you can do it, okay? We're going to have the same answer. All right, looking at the way I have it written, the 4 and the 5 don't share anything, but what variable do they share? The d. So we'll go ahead and factor that out, which will leave us with a 4 because we didn't touch that, d, and then plus 5. On the back half, notice that the 15 doesn't have a d, so we're only going to be taking out a number. It'll be positive because I want 2 positives and I have 2 positives, so I'm going to take out a positive. A positive what, though? What 12 and 15 share? 3. And again, your hint is, what do you want to factor out of 12 so that a 4 remains, right? So we're going to factor out a 3. And that leaves you with 4d plus 5. Yay, that's what I wanted. So 4d plus 5 is that common factor that we're going to pull to the front, 4d plus 5. And then d plus 3 is your remaining binomial there. Is that okay? The next two we have to be careful of, so if you've been working ahead, be careful. Remember the number one rule of factoring is to look for a GCF, okay? And a lot of times if you don't, your numbers start to get rather big quickly, and you're like, oh my gosh, I can't break this down. So if you get a really big AC, I always say take a step back and see if there wasn't a number you could have factored out. So looking at this one, 6x squared minus 2x minus 20, what can we factor out from the very beginning? A 2. And by doing that, you're going to notice it makes the numbers a lot more doable, all right? So let's factor a 2 from the very beginning. So remember when you factor out a GCF, you pull him all the way in the front, and you'll still have 3 terms behind him, right? We're just pulling out a common factor of 2. So what will that leave us with?
3x squared.
3x squared minus just x, or you can put a 1x, I don't care. And then what, minus 10? And don't pull a Molly. What do I mean by that? I don't know why, but I always get like the first one right, but by the time I get to the end, I like forget to factor out a 2. So I'll be like 3x squared minus x minus 20 or something like that. So remember, you're taking the 2 out of all 3 terms. All right, this 2 is going to be part of our final answer, but he's not part of our AC method. All right, so our AC method says take your A, take your C. So our AC is negative 30. We're going to think of things that multiply to negative 30, but add to what? Negative 1. So do you guys see how that's a hidden coefficient of negative 1 there? All right, so what has to happen? In order to multiply to be negative, we need 1 of each. And then what holds the negative sign? Since the negative is the B, the bigger factor is going to hold that negative sign. So we'll do 1 and 30, and the bigger one has to be negative, but that's negative 29. That's not going to help us. 2 and 15, but the bigger factor is negative 15, but that's really negative 13. That doesn't help us. 3 and 10, where 10's the negative one, but that's negative 7. 4 doesn't go into it, but 5 goes into it 6 times with a negative. That's the winning pair. Do you have to go through all of those? No. If you know, like, okay, 30 factors of 30 that differ by 1, 5, and 6, and go right to it, that's fine. All right, don't worry about the 2. The 3x squared is going to be left with a 3x squared. Then we're going to write a 5x behind it, a minus 6 behind it, and a minus 10 behind it. So this first term, 3x squared, is going to stay the same, and then I'm going to rewrite the middle term using these factors. Positive 5x minus 6x minus 10. All right? So we're going to look at the first 2. And again, if you wanted to flip-flop it because you really wanted that 5 with a 10 and the 6 with a 3, you can do it. But either way you do it, you'll always get the same answer. All right, so the way I have it, I don't have a numerical GCF, but I do have a variable that they share. What variable can we factor out? X. So it's going to leave all the numbers the same and just reduce the variable by 1. So what's that going to leave us with? 3x plus 5. Does that look right?
Yes.
Okay. So on the back half, I want 2 positives, but right now I have 2 negatives. So what type of number do I need to factor out? Negative, right? Because you want to factor out a negative because you want to change the sign. And I'm going to factor out a negative 2 because I want that 6 to go to the 3 and the 10 to go to a 5. So I'm going to factor out a negative 2. Can I factor out an x? No, because the 10 doesn't have an x. So negative 6 divided by negative 2 gives you a positive 3. The x we did not take out. Negative 10 divided by negative 2 is a positive 5, and that's exactly what we wanted to happen. So guys, we're at the last step where we're ready to write our final answer. So when we write our final answer, we're going to make sure we put it behind the 2, okay? Because the 2 was part of the factoring. So who can we factor out to put behind the 2? The 3x plus 5. But when you factor out the 3x plus 5 there, you're left with an x. When you factor it there, you're left with the minus 2. And there you have your final factored form. So just because the 2 wasn't part of the AC, it is part of your factored form. You had to factor them out initially. All right, my hint to you though, guys, say you're working ahead because you're like, oh, I get it, and you didn't factor out that 2. So you would have 6 times 20 was negative 120. So you would have had factors of negative 120 that added to negative 2. It would be negative 12 and 10. You would do all your math, but where you should know, so you need to know to pull out GCF here, or when you get down here, you would have had like 6x plus 10 times x minus 2. And 6x and 10 have that common factor of 2 that you could have factored out. So whether you factor the GCF here, or then when in your factors you notice a GCF and factor it out there, that's fine. Typically it's easier to do at the beginning. Yes, sir?
Does the order matter?
No. So when we're doing this, realize when we come in factored form, it's multiplication, right? This is 2 times whatever 3x plus 5 is, times whatever x minus 2 is, and multiplication is commutative, right? So with this, you might do this, and you know how I've been like telling you, oh, be different and flip the 5 and the 3 or whatever. You usually will get a different order, right? So he might have done it and gotten 2 times x minus 2 times 3x plus 5. It's all the same. All right, last one. Really big numbers here. I'm kind of running out of room, so I'm going to write mine down here just so I have room. What can we factor out of 18, 21, and 60? A 3. And then what variable? D. It's always your lowest. So they all have a d squared, right? So I'm going to factor out a 3d squared.
I always forget about the greatest common factor because I was just
You just want to jump in. What's 18 times 60? Something huge, right?
Yeah.
What do you get?
1080.
1080. You don't want to sit here and think of factors of 1. So that's kind of your hint. You're like, well, gosh, that's a big number. Go back and think, could I have pulled out a number and make it a little bit easier to deal with? All right, so we're going to factor out a 3d squared, which will leave us with what? 6d squared plus 7d minus, what is that going to be, 20? Does that look right? Still pretty big AC, right? We still have that 120, but it's a way better than 1080 or whatever we had. All right, so this 3d squared is going to hang out with us. But we're going to focus on this. So our A times C is still pretty big, negative 120, but that's okay. So we're going to multiply to negative 120, and we're going to add to 7. But I just want to show you, don't be scared of big numbers. It's the same method, 1 and 120, 2 and 60, 3 and 40, okay? We're just going to go through 120 and divide by that. Notice we're adding to a positive, which means our bigger factor is going to be the positive. So we'll have 1 and 120, but the 1 would be negative. That's 119, not what I want. Then you do 120 divided by 2. So you have 2 and 60, but then smaller factor would be the negative, and that is 58. Not what I want. You have 3 and, what's that going to be, 40, but the bigger factor needs to be positive, so that gives me 37. 4 and 30, 26. Notice I am going down, so I am going the right direction, right? 5 and, just 5 goes in there, right? 14. Is that right? Well, did somebody do 120 divided by 5? 24. I was off by 10 there. Will get me to 19. 6 and 20 will get me to 14. 7 doesn't go into it. 8 goes into it 15 times. Can you see that? I'm getting kind of low. There you go. There it is. What did negative 8 plus 15 add up to? 7. So this is just my don't give up problem, okay? You will get there. You will get there. Typically, don't start questioning it until maybe you get to a factor of like 11 or 12, okay? Usually you don't have to go much past 11 or 12. So notice we got all the way down to a factor of 8. Usually when you get down to 11 or 12, you'll have found something by now. All right, so we're going to keep 6d squared the same. We're going to write negative 8d behind it plus 15d behind that minus 20. So 6d squared stays the same, the minus 20 stays the same, but we split our 7d to negative 8 and positive 15, and then we'll go from there. So now we actually can take a number and a variable out. What number can we pull from 6 and 8?
2.
2, and then what variable? D. 2D. So that will leave us with what? 3D minus 4. Does that look right? So 6 divided by 2 is 3. 2 D's, you took one away. That left you with 1 D. Negative 8 divided by 2 was negative 4, and you took away its D. All right, 15D plus 20. Let's look at the signs. Notice here we have a positive and then a negative, and we already have a positive and a negative. So our signs are as is. So we're going to factor out a positive something,
5.
Positive 5. And you can do that either by knowing 5 to be the biggest number that 15 and 20 share, or you can do it by saying, hey, what can I pull out of 15 to give me that 3 there? All right, so we'll have 3D minus 4 remaining. Does that look right? So now we're at our final part, guys. We can pull this 3D minus 4 out and put it right behind our GCF of 3D squared. And then what will be behind that?
2D plus 5.
You got it. And again, if you wanted to check these big ones, you would have to FOIL this stuff first. So distribute all that to get this trinomial. And then distribute your 3D squared and later to get that one.